Why am I wearing a Nostromo uniform? Well, it's because I look good in it. Damn good. It's because Adam Ezekiel from the RPF did a run of these. I received it on Saturday. It is today, currently Monday, and I'm like feeling so good about it. I thought I'd wear it in the shop while I'm working and I get it dirtied up. This is kind of how I weather my stuff sometimes when I particularly love it. Hey, everybody. Adam Savage here in my cave with a very close personal friend of mine. This is Cain. This is a replica of the Cain robot from RoboCop 2, the villain from RoboCop 2. This is designed and built by Phil Tippett and his incredible team back during the movie. It is, in my opinion, one of the best robots ever designed and built for film. And this is a studio scale version. This is what they were using on the film as an animate. So this is basically both an animatable, what do you call it? It's a robot with a visible armature. And it was used for all the stop motion in the film. They built some large ones, some full size ones. This one was a gift from Phil to me a few years ago. And it's one of my all-time favorite robots. It's one of my holy grail pieces. I can't believe that I get to be its steward for a while. However, all of these pieces are plastic, and I want to repair and replace some of them. And I have been doing this slowly with his legs. I actually hired a friend of mine who's a machinist to do a bunch of work on the bottoms of these legs so they were supporting Brett Foxwell. And then I've been slowly going through every few months, and I take one part, like this part, let's see, like that part, that's a plastic casting, and I'll remake it in aluminum, like that one there. Yeah. I haven't been covering these on camera. Sorry about that. This is sort of like one of those self-soothing projects that I go to every now and then. So that's what I'm doing today. So what I've been attempting to do is replace enough of Cain's plastic with aluminum that he's fully self-supporting. Why are you doing this? Oh, okay, there you go. Is to replace enough of his plastic with aluminum that he can self-support. Because what happened was when I first had him together, he'd slowly sort of like resin creeps. And I had a rod up his middle section, but I still didn't love that. And so I have replaced, there's metal going all the way from the floor up to here. Then I actually don't mind this connection, this piece of resin, that could wait. The next connection that is super weak is this, which is one of the hips. And the hips have this whole, they are a very complicated part that uses, this part. I want to make two of these today. These are the hips of Cain, and I am going to make two of these from scratch. I'm kind of surprised about that. I'm going to make two of these from scratch today on my mill and on my lathe. Actually, likely mostly on the mill. So I'm not even sure how to start on this. This is a lot of work. Okay, so this, to remind you, this is the part I hope to make. And here is where we're at with this part. I have the holes drilled to the correct sizes. I also have the two threaded countersunk holes already drilled. And it's a really good order of operations. If you have so the way these work is, There's a hole here, there's a slit here, and there's a screw here. And the screw closes the slit and clamps down on the hole. Gives a really, really terrific clamping force if you get the tolerance tight. But you don't want to be drilling this countersunk hole on the tangent of a turned circle. You can do it, but you don't want to do it. You don't want to put that kind of side torque. It's just better if you don't have to do it. So I did all my hole drilling before I even cut the slits here. The slits is the next thing. And once I have those, then it's going to be time to fire up the rotary table or maybe the mill. Did the lathe? I'm not sure. I'm working that out in my head as I go. But slitting is the next thing. Oh, wait. So when one wants to slit, one uses a slitting saw like this. And so I will level this out and make these slices with this slitting saw. Ladies and gentlemen, I get asked all the time, what happens when you really screw something up? And I have. So I cut these parts out of some 1/2-inch aluminum. Then I drilled the holes. They are correct. I drilled the side holes. They are correct. Then, ladies and gentlemen, it was incumbent upon me to then cut this part down so that it looked like this part, right? So that it had a riser here and on the opposite side, a riser at the other end. And so what I was... all right. I get asked all the time about screwing up on camera, and we got a real doozy here. So this is the part. It is so ready to go. It has the big hole. It has the small hole. It has the side holes correctly offset with 832 screws. Everything about this is ready to go. So in order to make the next set of cuts, which would be to cut this circle and that circle and to allow them to be offset. So just picture that this circle gets cut here, and then on the other side, this other circle gets cut and leaves this like 150 thou of material in between. That was the next step. That was the next step for this. So feeling specifically like I needed a solid grab on this and I didn't want to hold down to it or put it on the rotary table, I decided to tackle it on the lathe. And as I often do, I did the first cut on the lathe off camera just to like wrap my head around it without thinking about the camera. Reader, I then made this beautiful cut and it cut perfectly on the lathe, except there's the hole and the hole should be on there. This is a wash. This whole part is a wash. Measure twice, cut once. All right, I think I have the energy. I think I'm gonna try and burn through this. So what I wanna do is set up a high time lapse and see if we can't cover the action that way. Let's try, shall we? Well, that was about 2 hours to get back to zero, maybe 90 minutes. There were some efficiencies. But now what I have is I've got the piece chucked onto the lathe. Can you see that? No, you can't. There you go. How's that? Hold on. I've got the piece chucked onto the lathe, and I'm going to cut it down like this one is cut down. Now I'm going to cut away that part. It's confusing because the small hole is the big radius and the big hole is the small radius. So it's a little confusing. When you are grabbing stuff like this with a screw through a slit, this slit is only like 20 thousandths wide. When you are grabbing that, the tolerance between this and whatever pin you've got going through is absolutely paramount. Like, you want it plus or minus 1 thou. If you're at like 3 thou, this thing will never grab. Seriously. It may grab. You can get, for this one, I hate to set hard and fast rules. Look at this. This is my This Old Tony. Look at that. It's so pretty. All right. We are doing good, everybody. Just in case you were wondering. A small setback. I have lost one gauge pin today, my .703 gauge pin, which is really annoying because what happened was I had just pulled it out of the lathe. I was polishing and making sure it was like not damaged by using it. And then the phone rang and I put it down somewhere and I lost it. My 2 thighs are, I'm doing good. So now what I need to do is I need to take off this whole section. I didn't want to do that on the lathe because I was under a poor mechanical advantage for doing that. All I wanted to do is clear these corners. And then so the operations are thus. I need to take off that and I need to take off that. I'm going to leave the sides parallel to do that because after that, I need to cut off this, this, and this, and this, and have these meet. And I'm going to do that using a rotary table, and it's an operation I have never done before, and I'm terrified of it. Yeah. I may just file it. Ooh, I may file it. I may file it because it's an aesthetic thing, not a mechanical thing. Look, don't hate me. I can take the shortcuts I want. So now that I still have parallel, that's the great reason why I wanted to make the sides parallel at the beginning, was because I wanted good gription. This was a flat made on the lathe, and I want to marry it to a flat made on the mill, and I can't afford to be off, like, at all. At all. My passes aren't brilliant here. I'm off by half a thou. That'll show up later. This one is really tight. I am going to finish this with some emery paper, and hopefully that'll bring this into the prettiness that I'm hoping for. Yes. We'll see. All right, I think it's funny that I ended up using the die filer instead of my rotary table because in the end, the die filer did a much better job. Or not a better job, sorry. The die filer just did a really nice, fast job cleaning up this part. Here's what it looked like at the beginning. Let's see, I've sanded all the way down. Yeah. Same here. So yeah, this was all die filer and then finished on a 400 emery. Yeah, I'm really happy with how these look. These are great. All right, on to this one.
And she's done, or he's done. Cain, this stage of Cain is done, and there is still something wrong with my Cain, which is every part of these two upper thighs are bilaterally symmetrical, and in one specific way I made them actually symmetrical, and that is here. The cap head screw is accessed coming down here and coming up here, and in the real one, it's coming down on both sides. I may end up remaking that someday. What you need to understand about this is, first of all, this is without a doubt the most beautiful robot that's ever been made in film. I'm not going to even qualify that. I love the Terminator, but Cain is a freaking masterpiece. And I'm a huge fan of Stan Winston and his design prowess, but we don't often, like, Phil Tippett is beloved as an animator and as a filmmaker. His design prowess is insane. And the Merrick Cheney and the group at Phil Tippett's shop that spent, I don't know, a year and a half making all these, or 2 years, making all of these parts for a bunch of Cains. The deeper I get into this, the more it blows my mind. And what it actually is a framework for me to just continually get better at machining, because my goal eventually is to replace all of the cast parts with aluminum parts so that he is fully animatable. Right now, I've gotten most of the chain from the ground up to his waist. I am missing this, but that might be the next part. These lower thighs are the next piece of aluminum, and then I'll have a full aluminum chain all the way up to the waist, and then it's time to start moving up. I've already had a bunch of work done on his inside. Brett Foxwell did that. The next step after that will be the internal structure of the arms, which is a level of complexity that's kind of mind-blowing, but we'll get there someday, I promise. Thank you guys for joining me for this one-day build, and it is always an honor to work next to this bad boy. I'll see you next time.